Hi, my name is Hayden Smith, and this is part one of the video series for using the Batlab from Lexlon LLC. So, if you are just now tuning into this project and are not familiar, this device is intended to help users with the testing of 18650 form factor cells. This is a common project form factor, or a common cell used in many hobbyist projects, and we felt that there was a need that was not yet fully addressed to streamline the testing, and so we ran a Kickstarter campaign that was funded in last year, and we're now at the stage where we have shipped out all of our Kickstarter units and are ready to enter into the next phase. So the purpose of this video series is to equip people who have the units in hand with how to operate the Batlab, but also to educate those who are just now tuning into what this project is about with some of the general functionality of the Batlab project. So just to jump right into it here, the Batlab base unit is equipped with 4 cell channels that are all independent of one another. So the idea here is that you'd be able to construct a series of tests that you want to use on your batch of cells, whether they be 20 or 30, however many cells you have in your project. And you'd be able to configure those test parameters. What's your voltage cutoff, your voltage on the higher end and lower end of your cycle tests, your temperature constraints, charge rates, etc. Build that into a test execution file, and then just run with it. The software could help the user by prompting them into which Batlab unit to place the cells into, when the test has completed, when to switch out the cells, and then output that information from the tests into a measurement file that's easily read by the user and can be used to determine when cells are ready to be recycled, and or how to match cells together optimally for a particular application. Each of the cell channels on the device is capable of charging at up to 4 amps. That's independent of one another as well, so 4 amps per cell channel. The maximum voltage that can be measured on this device is 4.5 volts per cell channel. And the device itself is powered just based off of USB connection to a host computer. So this is for transferring the information from the device to the computer, but also to power the measurement and communications processors that drive some of these LEDs that you see on the PCB. The discharge and impedance functions of this device can be leveraged just by the USB power connection. However, if you want to use some of the charging features, then you will have to apply additional power via the 5-volt external power supply input. So that's what you see connected with these alligator clips for demonstration of the LEDs at a later point. A lot of people who have seen this device thus far have been asking us about what these red dip switches are. So as part of our Kickstarter campaign, we ran a survey to determine what features would be valued the most by the users. And a popular remark was that it would be great if this device could be used to test cells that are not of the 18650 form factor. So we heard that feedback and we incorporated it into our design by way of external cell headers that the measurement processors can defer measurements to these external headers when these dip switches are configured in the downward position. So for instance, if I want to defer cell channel 0's readings to the external cell input, then I would flip all these dip switches to the downward position, and the measurement processor would be reading from here. And each of these inputs corresponds to a different parameter that are labeled on the PCB. We have current, voltage, and temperature there, with the positive and negative terminals there. So that allows users to leverage this device not only for these 18650 form factor cells like you see here, but also for maybe other cells they have on hand for their projects. So I mentioned before we've got some LED headers on, or LEDs on board to give some indications. The power LED on the far left is really just to show when the USB power is applied. So if I plug this USB cable into my host computer over here, we will see the device go through kind of a boot phase and then solid on the power. The external power indicates when the external PSU is applied. So this is required again for charging features. And I do have an Explorer board here, having already applied 5 volts. I just need to enable it. So I've enabled the 5 volt on my host computer, and we do see that EXT power LED turn on. The message LED here, this is used to indicate which unit for multiple. So if you have multiple Batlabs, this LED is used to communicate which Batlab should be populated with cells at any given time. So the software, once it is polished and the graphical user interface is ready, would be capable of kind of walking users through the whole test process, from providing kind of a cell naming scheme to prompting users based off those cell names to put them into their Batlab units and walk them through and alert them when that cell is completed testing, etc. And this LED can be used with different blink patterns just to indicate to users, hey, this is the Batlab you need to be populating at this point in time. The comms LED just indicates that we have connectivity to the host computer and transfer information is occurring. And then finally we have some LEDs over here on the right side next to each of the cell channels. These are used to indicate information about the mode that that cell channel is in. When I say mode, I am referring to a state machine that's internal to the Batlab firmware and provides information such as whether the cell is charging, discharging, doing an impedance test. Is the cell backwards? Is it of the wrong polarity? Is it not testing? Is it in the idle state? Is there no cell in the channel? Etc. And that information is also documented in a Batlab hardware user's manual that is in the description of this video. So that can be used to see the different blink patterns, but just to demo really quickly with this device connected, if I were to take this cell right here and place it in with correct polarity, we would start to see the following blink pattern. If I took my second cell here and put it in reversed, which is not correct, we're going to see a separate blink pattern on the device. So that kind of gives you a heads up when things are going maybe wrong. If the cell testing has stopped for any given reason, you can quickly reference that. And if you're familiar with the blink patterns, you'd be able to know what's going on. So that kind of covers the device from a high level here. On the top right, we do have some extra headers. Those are actually not populated with the units that come fully assembled. Those were kind of for development purposes here, but these buttons can be used to reset the measurement and communications processors if the need would ever arise. So that just about covers the most obvious features of the unit. A lot of this material again is covered in the Batlab user's manual, which we hope to update as time goes on with maybe some of the questions that we haven't yet answered here. But this really concludes part 1 of this video series, and we hope to see you for the next video, in which we will cover the state of Batlab Python library that can be used to communicate with the devices that are out there in the interim before we have fully finished the software GUI. So thanks for watching. We hope you liked it. If you have any questions, please just let us know in the comments below, or reach out in an email to our support email address. Thanks.